Okay, ladies and gentlemen, let's start at the begin meetings. Okay, I know our next speaker quite well. He has an extremely ferocious CV, so with apologies, I'm going to cherry pick a little bit. Naimish Patel was the founder and CEO of Gridco Systems, a leader in agile grid infrastructure solutions. He was also one of the 4 founding team members of Sycamore Networks, a leading provider of optical networking solutions for mission-critical networks. He also obtained his bachelor's and 2 master's degrees in electrical engineering from MIT, and he currently serves as the CEO of Fauna Systems. Naimish, the floor is yours.
Thank you, John. First of all, I think my CV is actually a liability amongst this group, by the way, not an event. Before we get going, since I believe this is the last of 2 slots, I wanted to just thank Josh and also Catherine for their steadfast leadership and bringing us all together. I also want to thank you for the fantastic talks that you've given and the very thought-provoking questions you've raised. From my perspective, I actually can't think of a conference or a workshop or a gathering I've been to in my life that was focused on such fundamental and thought-provoking topics. So I think, Josh, your vision of this being emblematic of the Solvay conference in spirit, I think you've collectively achieved it.
Thank you.
So I'm in the unenviable position of having to follow all of your talks. I wish I had something technically compelling or as fundamental to talk about as you all have. The best I could do is probably regurgitate some of it. But with that said, what I thought I would do today is try to explore and extrapolate. What if you take the capabilities of engineering with agential systems and agential materials, and you extrapolate 20, 30, 40 years from now, what type of society, what type of macroeconomics could this unlock? That's what I'm going to explore today. But before I do that, I actually thought I'd start with a personal story. I think it's relevant because, well, you'll see why it's relevant. It also happens to take place just across the lake. In 1986, so I used to be a musician a long time ago, a violinist. And my parents would send me away every summer to a place called the Meadowmount School of Music, which is based in Westport, New York. It actually overlooks Lake Champlain. I think, in retrospect, they probably did this to get rid of me for the summer, but purportedly I was there to learn how to be a better musician. It's a school that, with a storied past. It was founded by a fellow named Ivan Galamian, who was the teacher of the famous violinist Itzhak Kromer. So my last year there, I think I was 12 or 13, and it was the evening when my parents were supposed to pick me up. And so I'm there, all my fellow students have left. Their parents have already picked them up. I'm still waiting. There's a dorm monitor dutifully delaying her departure on my behalf. About 7 hours later than my parents were supposed to pick me up, I hear a car coming across the gravel. Rainy night, windy night. Turns out their car had broken down. So they picked me up. I was sort of relieved that it was just that. And then on the 5-hour drive back to our home in just north of Boston, my parents revealed to me that my mother, just earlier that day, had been diagnosed with non-Hodgkin's lymphoma, stage 4. The doctors had expected that, or given us the expectation that she would have another 3, maybe 6 months to live. So when we got home, she started a treatment of conventional approaches, chemotherapy, radiation. She had actually 2 bone marrow transplants. But then this miracle arrived in the form of a phase 2 clinical trial of something called alpha interferon. Alpha interferon, for those of you who may not know, was actually the first genetically engineered immunotherapy drug. This is 1986 we're talking about here, right? So there, as I said, there was a phase 2 trial. She fortunately became a patient in that phase 2 trial. After 3 doses per week over 3 months, she was declared cancer-free and has been cancer-free since. She was only one of 4 patients in that 100+ cohort that survived without the alpha interferon. I bring this up because alpha interferon happens to be emblematic, in my opinion, of both the fundamental challenge in bioengineering of today, but also the solution, many of solutions of which we're talking about here. And I'll get into why that is. Okay, so let us first talk about, I wanted to give you a sort of macroeconomic view of how well bioengineering is performing today. I'm not going to talk about the technology, I'm just going to take an outsider's view as how bioengineering has impacted specifically pharma. Why pharma? Well, it's sort of the most well-known application of bioengineering. It's not the only one by any means, but it is also one that exhibits the biggest challenge. And let's get into what that challenge is. So it's fundamentally an economic challenge. So pharma is actually the only industry I can think of, and I've racked my brain to think of others that have this property, but it's the only industry that exhibits a diseconomy of scale. And what do I mean by this? If you measure the output of the industry in terms of the number of drugs per unit, dollars spent per year, it actually gets worse and worse and worse every year, and has done so, by the way, for the last 50+ years. The number of drugs per billion, inflation adjusted of course, but $1 billion of industry-wide R&D has halved every 9 years for more than 50 years. Now, this is not because there isn't innovation. Clearly drugs are coming out. Clearly things are getting better. But just on a purely economic basis, it has a diseconomy of scale. It's actually got an inverse of Moore's law, right? In microelectronics, you get more for less every year. The even more surprising thing here is that we're getting less for more out of pharma, despite the fact that the inputs are actually following Moore's law. In fact, genomic sequencing is actually following a super Moore's law, and this is a key enabler in many of the innovations that underlie pharma. Furthermore, structurally, the industry has been very focused on getting efficiencies. So a lot of what was done internally in the development of biologics and drugs in general has now been outsourced. CROs do the vast majority of work except for the upfront work. So the efficiencies in scale are there too. So why are we getting less? This is a strange result. Again, I can't name any other industry that exhibits this characteristic. We'll come back to this question. Okay, so people understand this. I'm not saying anything new about it. So what has been the response of the industry so far? It's been twofold. One is, let me target smaller patient populations and subsets of diseases in hopes that I will maximize my likelihood of success. Right? That's been certainly the recent trend over the last 5 or so years. So-called personalized medicine. Right? Traditionally, big pharma took the biggest of the problems, or at least the biggest of the expected diseases, because they represented big markets. So if they were going to invest $2.6 billion in R&D, they wanted the most output they could get. Government sponsored the things that the private sector never wanted to sponsor and work on, and the VC-backed biotechs did something in between. The challenge here is, if you focus on personalized medicine, where the cohorts of the patient and thus the market size is smaller, your success rate better be higher. Today it's 1 in 10 work. 1 in 10 get through the FDA. So instead of 1 in 10, it better be, 1 in 5, 1 in 4, 1 in 3, right? Otherwise the economics simply don't work. Your development costs are largely the same. So this is actually what most companies are now focusing on. Some with success, but the vast majority without success. So some have said what the industry needs is what they term an inversion of spend. So today, if you look at how you distribute the dollars in development across preclinical activities versus clinical activities, the vast majority is in clinical activities, of which 10% survive, meaning 10% succeed. So some have said, okay, let me spend a lot more on simulation, 5-6x more in simulation, so that I can get from a 10% success rate to a 90% success rate, and then validate and spend fewer dollars on validation. That's what some industry experts have said. And how would they propose doing this? It's more of what's done today. Simulate, do organs on a chip, massively parallel cellular screening, computer vision, computational chemistry, and the like. The challenge is nothing's changed. This proposal just extends the same approach we've taken to developing therapeutics that we've done over the last 50 years. One might term it a Feynmanian approach. It's a reductionist approach. Feynman is famous for once saying his Caltech freshman physics class that biology is rooted in chemistry, which is rooted in physics. So if you understand what happens at the atomic level, you understand what animals do. I mean, I'm paraphrasing, but that's the essence of what he said, right? Clearly, that's not the case. We actually do have an understanding because of Feynman at the subatomic level. It's actually the most successful theory in all of physics, QED. But has that given us a practical understanding of how to engineer or even understand biological systems? The answer is clearly no. Okay, so with that said, it seems like all doom and gloom, right? It's not actually. There's two recent examples that actually buck the trend that I was just talking about. And this relates back to alpha interferon. Remember I said alpha interferon was the first genetically engineered immunotherapy cancer drug? Well, if you look at CAR-T, its history is actually somewhat related to alpha interferon. I don't know for those of you who may not know what CAR-T is. CAR-T is, I would say, the most recent approach and formalism to trying to solve certain types of cancer. What it essentially does is it takes your T cells, it extracts them, genetically modifies them to help them target the cancer at issue, and then reinserts those T cells for further proliferation within your body. And by the way, when it works, much like with alpha interferon, it works spectacularly well, meaning it not only reverses cancerous growth, but it actually solves it for as long as our observation periods allow us. Compared to other results, clinical results for cancers, when this works is spectacular. And has even been shown now to be able to address certain types of solid tumors, not just liquid tumors. So this is an exception to the trend. We'll get into why it might be. COVID was also an exception to the trend, right? Both from the perspective of how much money it took to develop a vaccine, but also from how quickly it was done, and frankly, how effective it was. Both the COVID vaccine and CAR-T have something in common that I believe is fundamental to their success. And what's common is that instead of trying to micromanage how the immune system evolves and reacts to the pathogen of interest, it stimulates the immune system to leverage its already intrinsic capabilities to do so. It's finding a signal, it's finding a stimuli for your immune system to do what it already does well, and then not micromanage it thereafter. Sound familiar? Well, so if we take that idea, which is the core idea I think that underlies our last 2 days. Where we've gone wrong in pharma to date has been that we're trying to engineer living systems without recognizing that they have their own objectives. They have their own desires. So when we design a drug, we have this sort of static, almost like bridge building mindset in our head, which is, I know what the load is going to be, I know what maybe the wind conditions are going to be, I'm going to predict everything about the environment possible, and then I'm going to design something bottoms up to meet those requirements. The problem is when you're dealing with living systems, you can't possibly enumerate all of the conditions. You can't possibly enumerate how it's even going to react to what you introduce. So instead, turning around the idea that you're dealing with a static system and making the assumption that it's going to do something in response to whatever you're given has to be the basis for engineering. And if you're able to find the stimuli that elicit the function or behavior that you want. The great thing about making the assumption that these systems will evolve to their goals is that you don't have to do anything thereafter. I mean, I'm sort of, maybe there's a little bit of hyperbole there. But the point is that you don't have to micromanage the process. And so now the approach to engineering becomes, how do I convince, how do I collaborate with this material? Remember, this is the regurgitation part of the talk, because you've heard Mike and Josh and many others say this multiple times. But it is important to reiterate that engineering now becomes almost like prompt engineering for AI. It becomes focused on objectives and stimuli rather than mechanisms and physical modifications, right? So what are the potential benefits of taking this approach as compared to previous? And when I'm talking about benefits here, I'm sort of loosely talking about technical benefits, but more importantly talking about potential economic benefits. So once agential systems, imagine you're able to somehow instantiate a new objective into an agential system. The hope and expectation would be is that you now get a far more robust and predictable response from your function calls. This is actually the fundamental challenge in pharma. Pharma, you don't get predictable or robust responses. Why? Because the conditions are different, you don't understand the internal state of the system, and so on and so forth. So from a performance perspective, this is actually the potential benefit of taking this engineering approach. Another potential benefit is you should have resiliency to internal part failures. Because again, the objectives sort of cascade down. Once you're able to instantiate an objective at a high layer, that sort of gives rise to a changing of objectives at all the lower layers that support that higher layer. So even if there's failures at lower layers, the objective still remains, this remains true. The lower layers will find a way to achieve that objective. Now, from the micromanagement perspective, the clear benefit here is that, again, if there's a library of function calls that you've been able to discover, the engineering time, cost, and complexity in eliciting the function that you want from the agential material should go vastly down, right? In fact, incidentally, here's another analogy with AI, right? AI for code generation may or may not be better, particularly if you look from the perspective of performance. But you know where it guaranteed is better? Development cost. That's why it's happening. That's why people and industries and enterprises are adopting AI code generation. Because you don't need as much, it costs far less. This is an analogy, I think, here, which is this may indeed, from a commercial perspective, be one of the main reasons that engineering with agential systems is able to take hold in solving certain problems. Lastly, there's sort of an ecosystem benefit. Again, once a library of function calls has been discovered, what it does is it opens up bioengineering to a much larger class of talent. Much as AI and prompt engineering is now accessible to a larger class than software engineering, right? Larger class of talent than software engineering, so too will this enable a far more vast ecosystem of talent to be applied to problem solving. That implies also lower capital costs. And that further implies broader investor bases. So instead of having to go, as you do in biotech today, to one of, 24 biotech investors with large funds and expertise, now you actually could go and fund your idea from a much more vast populace or cohort of VCs. So the ecosystem benefits are significant. So if we map back from the methodology to what we need to do over the next decades, I think, again, Mike and others have mentioned this multiple times, but there's different layers, hierarchically, that you could apply the agential engineering methodology to. I would argue today that going back 10,000 plus years, we've been doing this. We've actually been doing agential engineering at the behavioral level. How did we domesticate the wolf? We have dogs everywhere now. That was perhaps maybe one of the most successful examples of engineering with agential materials. How did we domesticate crops? So it's not that we haven't done this before. It's just that our technological capabilities have limited us to doing it at the highest level, the behavioral level. The last 20 years, I would also argue, has enabled us to start doing it down here and a little bit here, the genomic space and the transcriptional space. You may not think this is engineering with agential systems from a methodology perspective, but that's probably what it looks like when you actually apply it. You're changing hardware, yes, but at that level, that's your only option is to change hardware. So I would argue that between the top and the bottom, we already have done it. Where it's hard, and where there's much discovery to be made, is in the middle. Transcriptional, proteomic, metabolic, anatomical, or morphospace, and sensory and navigational space. To make usable products that replace conventional methods across a variety of industries, these are the things that we now need to tackle. And for each of these, there's a series of questions. How do we read the internal state of the system, of the agential system? And also, how do we instantiate new set points or objectives in it? What are the physical mechanisms by which we can accomplish this? And how robust and composable are the function calls both within a layer and across layers? By composable here, I mean, if I want function A and function B, can I just make function call A and at some point later function call B and assume that they don't interfere? Or can I do function A and then apply function B on function A? This is what I mean by composability. How modular are these function calls? What do we need to do to be able to make them modular? So what this eventually will give rise to, in my opinion, is two things. There's going to be a discovery engine for each of these. A discovery engine that's high throughput. It's designed to address the key requirements of each of these phases within interventions that are appropriate for each of these levels. But eventually that centralized discovery automation will also yield sort of the equivalent in AI parlance of the inference engine. So we've got the training and discovery. We'll also need inference engines. Why? Because to ultimately deploy this capability, you'll want to take those discoveries and deploy those discoveries in the field. And you'll need physical things to do that. So for every discovery physical mechanism, there's going to be sort of an inference or a deployable mechanism. And ultimately, individuals will be able to use these to access the space that agential systems can explore themselves. So, at least at Fauna, our view is that this centralized discovery and automation engine is the core asset that needs to be built. Not just for Fauna, by the way, but for the industry. Because it is this automated and high throughput methodology that will give rise to sort of these hopefully modular and hierarchical function calls, the library of function calls. Once those are there, then that gives rise to commercialization opportunities. But without that, you really don't have anything. And so our focus is largely on this, but providing commercial feedback, commercially relevant feedback into this engine to be able to refine the output. So if we look forward a little bit, here's sort of the axes in which one could imagine the impact of agential engineering across industries and the level of impact and the depth of our agential prompting capability. So you can imagine that for a particular industry, we can start generating sort of what I'll call components. As those components become more mature, those can be composed into systems. And ultimately, we're actually creating ecosystems. I mean, living ecosystems based out of these agential materials. We'll get into that a little bit later. The depth of quanting, I sort of mentioned before, but you start at the top level, and it seems to me that the evolution will be to finer and finer granularity functionally, both in time and space, and depth of function call. So I think naturally you'll start at the top and move down. It's sort of the complement of the reductionist approach, right? The reductionist approach starts at the bottom and is trying to move up. It's having challenges moving up. But this is sort of the complement. And then, of course, there's plenty of industry verticals, right, that you could imagine this impact. So, Fauna's focus initially is sort of as close to the origin as possible, really. It's focusing on simple functions that are still commercially viable and useful. It's focusing on a few industrial verticals that seem to exhibit a need. We still have yet to identify how to solve those needs, but that's our goal. And we're still squarely focused at the component layer. We're not, for sort of issues of the maturity level of the technology, we're not ready to move into systems and ecosystems. And the way we're going about this is in some ways like agential engineering itself. There's two tracks of work. There's work in the lab, demonstrating core functions, and then there's work with potential commercial partners to identify problems. Intersecting these two and iterating these two is the work we do. This is almost like what Mombot is doing. Mombot applies interventions. Interventions in this case are sort of like the functions, and then then Mombot assesses, was that intervention successful? Well, our means of assessment is it commercially valuable? Is it commercially viable? And we just keep doing this, feeding back. So that's been our approach and will continue to be our approach. But if we take this now and extrapolate far into the future, what can or could the impact of engineering with agential materials be societally? Let's start with economically. One of the amazing things about agential materials is that you couldn't conceive of a more future-proof material. It has been imbued through its evolution with so many latent functions. The limiting factor today is our ability to understand how to call upon those functions. So, what does that mean practically? If you build a system out of an agential material, my goodness, you could use that material ad infinitum. As our ability to discover those function calls and handles matures, we could use that same material, deployed in the same manner, but utilized differently through our interface with that material. So, let me give you an example. Imagine you start building your home out of agential materials. So you build the walls out of nominally wood. Maybe it's cellulosic types of cells. Fine. You've coaxed them into the right shape through the anatomical compiler, and it's doing everything from insulating your house to regulating the humidity in your house to perhaps regulating the oxygen content, and is doing so adaptively. And by the way, if you nick it you put a painting on the wall and you nick it, it will self-repair, as long as you're feeding it nutrients of some form, right? Well, then you say, 5 years later, you say, okay, I actually want some bioluminescent capabilities on this wall. Get rid of my conventional LED lights. What would that involve? It might involve simply bringing your equipment that enables you to interface and communicate with that agential material to the point that you want to infuse with bioluminescence, doing that and waiting some time for it to grow the capability to do it. So, the amazing thing about agential materials with respect to passive materials is passive materials are designed, optimized, and manufactured for one use and one use only. But agential materials, at least in principle, can be future-proof for a long time. This has major implications at the macroeconomic level. Today, society is excellent at building something, using it for a short period of time, throwing it out, and then building it again. We've gotten very good at that. And by the way, that drives GDP growth. That's a separate conversation. But for mature economies like ours that go to extraordinary measures to eke out 3% GDP growth, in my opinion, GDP growth is not what we should be shooting for. We should be shooting for productivity-driven growth and growth that yields lifestyle enhancements. It seems to me that engineering with agential materials could have a totally profound impact on the way we grow economies because of its impact on capital efficiency. I think that's one major impact, but again, this is extrapolating in the future, but I think could be very profound. Let me also talk about sort of some other societal potential extrapolation. I mentioned before, our domestication of the wolf into dogs is in some ways the most successful example of agential engineering. You fast forward, we're going to be doing this at a global scale. We'll be applying agential engineering to everything you could possibly imagine and impacting every industry you could possibly imagine. So what does that type of society look like in the future? So all industries will become refactored around their supply chains, leveraging agential materials. Not all, but many. There'll still be need to build things out of steel and carbon nanotubes and so on. But agential materials will infuse many industries and transform them. Economies will refactor around capital efficient growth, but they will also become more balkanized. Why? Well, today, our reliance on things like rare earths creates an interdependency between different nations. If you extrapolate what you do with agential materials, what do you have to feed them? Ultimately, it's water and nutrients. And then the discovery capability to turn them into what you need them to do. So, to some degree, you actually reduce your dependence on other nations. And that's true at both the level of a nation, but perhaps also at the level of the individual. If you can turn your home and alter its functionality by downloading the macro for bioluminescent walls, you're doing that yourself. You're not relying on even another entity to do that, other than the knowledge domain that you're relying on. So as individuals, it seems to me we could evolve to become more capable, but also more self-reliant, collaborating directly with the ecosystem in which we live. I actually think that CEOs per capita will increase drastically over the next 2-3 decades. What do I mean by this? If you're imbued with more capability, we're already, by the way, seeing this with AI, right? The number of companies that are sort of natively AI enabled, that are generating 10 million plus revenue with one person, is rapidly increasing. There's already $1 billion company with one person, right? So AI is just step one, but AI only allows you to do things virtually. Engineering with agential materials also adds the critical enabler of being able to do things physically. You put those two things together, now we as individuals will be capable of doing vastly more, and perhaps inconceivably more, than we do today. And that's what I mean by CEOs per capita. And by the way, probably with CEOs, it might be even CDOs per capita might increase drastically too. So I think society will become ultimately sort of irreversibly integrated and collaborative with all of its supporting infrastructure. And then perhaps an ethical question ultimately arises, which is, will this collaboration with all of our surrounding infrastructure become more subjugation in either direction, or will it become symbiosis? I hope the latter. I'll leave you with that.
Really excited to see what Mohammed does in the next couple of years. One thing that we as a group in this conference have not talked about at all is the question of ethics that you kind of ended with, right? Like, Mike does these three-headed planaria, and it's really cool science, but I always kind of wonder, like, anybody ask the planaria how they know about this? Like, there's no moral problems associated with like melting down steel and building it into a burger. There could very conceivably be moral problems with engineering around certain kinds of materials. So how do we have that conversation, ideally before we do something catastrophic?
Yeah, so first of all, I don't purport to know the answers to that. I think that's a complicated question. What I would say, however, is it's not something that is fundamentally new, right? When we domesticated the wolf, and we now have dogs, do we have an ethical issue with that? Have we subjugated dogs? I mean, in some cases you could argue we have, but we don't have rules against it. We don't have laws against it. We don't seem to have a general moral issue with it. But you're right that if you extend the capabilities of this technology to its sort of almost illogical extreme, you know, all the infrastructure around you ultimately becomes living itself. It has its own desires. You modulate its desires to your effect, just as we do with dogs or cats. Maybe cats less so. But the idea taken to an extreme, I think, does yield important questions. You know, should your house have rights? I mean, it's evolving. It has its own objectives if it's built out of agential materials. Are you asking too much of it? I don't know. I don't know the answers to questions, but you asked the right one. Yes.
Yeah, sorry, Naimish, before you take the next question, if I may, I want to also offer Jean-T Luzov the opportunity to answer Thomas's question.
Please, yes, an expert in the audience.
Yeah, we definitely should have done introductions, again, via culpa. For those of you who don't know Jean-T Luzov, she is a bioethicist and philosopher and spends all day, every day, thinking about these kinds of questions. So, Jean-T.
I think these are really questions of the future, to reply to your remark about rights. But so rights are something very far down the road. So there are many types of rights. Talking about rights, which in traditional ethics also means the duties on another side. If someone has rights, someone else has duties. I would not start at that end because I think that's really the far end. I would think about a change of the moral landscape in terms of how we the type of values or the categories of values that we attribute to these novel phenomena. You mentioned the domestication case, which is really one of the classical cases also used in debates it's not new to breed. Because that was what was done. Rules were bred to be functional for humans. However, that is it's a question in whether that applies to agential materials, and I do not think so. I think this is really novel. That we as philosophers are speaking for me, philosophy comes before, ethics in the what people think about when they hear ethics is like classical bioethics, like consent, rights, and duties, responsibilities, and so on. You need to start much earlier, much say more to the left side, where you ask the ontological question, like
the
what
principles.
is this? And only when you have really explored what it is, and by the way, it's a dynamic thing, so it's not going to be, it's going to be taking shape over time. Then you can take the next step, asking, okay, so and what should we or should we not do with this? Are moral questions applicable to it or not? Because not everything is amenable to ethics. At the end of say the pathway that I designed in working with time scientists, there is the translation into real life, into products, and then you get questions like patents, licenses, misuse of what you thought you had developed and so on. So it's really, it's a long road, but it would start. I think that this is so novel, there's not much work on essential materials. And then, yeah, that's why I'm working with these folks, because I'm sort of, as a philosopher sitting in the source, I'm working on that. And I'm like event like this, I'm learning from what I hear from patients. And then the philosophers think slowly, so I will only think later, reflect later on it. But yeah, but Thomas, yes, you're basically a forthright. This opens up like new avenues, and it requires rethinking.
Can I make a comment on that question?
Okay.
So, if you hike in the Himalayan foothills where it is very difficult to find raw materials for building any structure, you find that the indigenous communities have built these massive bridges just out of living plant roots across rivers, right? And the beauty of it is that it is not just living trees, they are constantly adapting. The more traffic there is, the more stronger the roots get. They don't have to be told what to do, right? If there is a catastrophic flood, the bridge adapts automatically, right? So, in that essence, you don't even have to tell those local communities that you have to be modeled, that you have to. It is what
It's happening automatically.
That this is a living entity, right? So I guess it requires some level of tuning ourselves to what is around us, right? And be aware of that. And then nobody has to tell you, oh, be moral or be ethical, right? It automatically will happen if we pay attention to what is around us. So I just want to.
That's an example of symbiosis.
Yeah, sure.
Yeah. I know you've been waiting for a long time. Go for it.
Where do you see, this is another super easy question, softball really. It's very metal, it's super cool what you're talking about, this is as applied to medicine. But if it becomes that easy or relatively solved, that we can use agential materials to affect like human health and society, or you build your house out of a mushroom or whatever. If it's agential, I mean, like where do you see like fauna systems or a company like that? What is their role in the opposite? Or I could hack your house to make it smell like farts? Or like, if it's agential, that means it's tunable by anyone.
Yep.
Technically. So as you develop technology, I'm sure you have responses to this as well. I just want to know. Where do you see, like I would say, a company's role in how you develop these things very tunable? Do you try to hide the fact that it's that tunable? Do you inbuild defenses? Or is that even something you think about?
Well, like with any new technology, right, there's going to be gaming of it by adversaries, right? And that's where I do believe at some point there will need to be a regulatory construct for what is allowed behavior. First of all, and it's not just behavior, it's who owns what.
Yeah.
It's what is subject to privacy. What things shouldn't be hacked, what boundaries shouldn't be crossed. I mean, there's so many different sub-questions of what you're asking. From a moral perspective, I think that we all agree that, what fauna is about ultimately is enabling an ecosystem. Now, to the extent that the enabling capabilities we provide, particularly around the discovery of these sort of functional calls, there may be a need to curate the function calls to avert malicious use.
Yeah.
I don't know what those would look like now, but I do believe there is a responsibility by any company operating in this space to forge a path that gives rise to beneficial uses and minimizes malicious uses. But there's always going to be adversaries. Mike?
Yeah, thank you. I just wanted to say one thing that I think is important to keep in mind, which is in terms of opportunity costs for those kinds of questions.
Yeah.
So if you consider what's happening in factory farming, confinement, medical suffering. There's no scenario under which, none of this happens, and everything stays cool, we don't ruin anything, we don't subjugate anybody, everything's great. That scenario doesn't exist. What we have now is a massive amount of suffering induced by ignorance, And I'm not saying we can't make mistakes and make things worse, it's totally possible. But it's often, those kinds of things are thought about as if everything's great, and you scientists better not make it worse. And I think it's very important to understand that right now, what's going on is completely untenable. It's untenable on the biomedical side for the kind of emails I get, it's just unbelievable. The environment, what's going on with the environment. We could talk about three-headed birds, but we have factory farming of mammals and birds, and you can't even the fact that these questions of did anybody ask the pigs, did anybody ask the cows? No. So I think it's very important to just think about the opportunity cost of not doing it equally with what are we doing here. So that's really good.
I can say that actually for doing that as well. I think one of our roles with government systems and actually, let's say, a commercial endeavor of bringing some of those ideas to reality is to find the right niche. Because, again, there is, to have success, we have to find, let's say, natural problems to solve at a scale which is natural or commensurate with the size, let's say, and function of the essential materials that are being used. You live in a world which has certain scale, let's say, regularities. You don't have people or plants who are 100 meters high or something like that. There are some natural constraints, I think, on Earth to utilize those things. But from my perspective, I think you would agree, I think one of the discoveries is to find the natural niches to actually operate here. So one clearly interesting aspect is first to understand how you sense the environment from the perspective of living systems that you don't necessarily see and yourself as a human, which they do sense, so something to start with that. But of course, in the future to build upon, building blocks first, because I think that one obviously can try to there's two aspects. There's building with essential materials or improving the essential materials themselves to actually have structures which are built on that, like those bridges that you mentioned, right? So those are two different aspects, an aspect of manufacturing and an aspect of actually producing something which is related to at a higher.
I think that's actually really interesting, the higher level potential, like thinking about biosensors, like dogs are really good at sensing, they have all the receptors in their nose. Is that something, we go that high level to think of okay, because it was interesting when we were talking earlier in the lab, it was like, we're going to observe gentle materials. Okay, I'm expecting some type of material that is like some material, but I don't know, it's actually this mentors and I'm like, oh, it was this, so and it's nothing new. It is actually a living thing. So how high order level would you work with? Like, would you work with trees and other animals to train them to become more fit for purpose? Or is it all on that, xenobot level?
I think so. There's a history of already doing that, and so I think that from the perspective of doing something new and unlocking fundamentally new capability, rather than extensions of what is done before, our focus is on mesoscale. The things you saw in the lab, right? Think 10,000 to 100,000 cells, or 1,000 to 100,000 cells worth of stuff. In part because at that scale, there seem to be problems, at least based on our conversations today, that don't have good conventional solutions, and that a Xenobot-based approach could, at least in principle, be a good candidate solution for. Those won't be, to the exclusion of, in your terms, higher level agential sort of functions, but I think that's more trodden on space. meaning that space that's more trodden on, meaning there's already activity there, as compared to the mesoscale.
Yeah, because I think that's why I really like your example of the bridges, because the agential materials have like a purposefulness in themselves, it's inherent. And there is a need to really moving away from the anthropocentric views and making things like we would like to have that, because like is your bridge. So suppose, so you said like if the depths to like flood or anything. So suppose you would think like, oh, we're going to put some fertilizer there, but then they're going to grow faster. Now, look what happens to your plants in your house when you put that fertilizer. They get growing, but they get like totally weak, so the bridge would totally collapse. So there would be, their intervention in this, in the sort of homeostasis that is inherent in agential material would be completely, made a lot to be disturbed or perturbed or whatever you want to call it in these terms. If you from a human point of view, like start with interventions that are not within the purposefulness of the material. So it's very clearly to say that respect the nature of these materials. How to do it is secondary. And then you have like the engineering, like how far should we go with the engineering, with these materials? There may be a natural limit, like, it's a bridge, like you do too much. From our human perspective, you're actually going to destroy the system.
But I think the point was that if we could say make a quote unquote new agential material that has the best of both worlds, then that would be implied in that space, right? Without having to compromise a lot of properties. So I think that's probably what it's getting at, which is great.
Can I just make a quick comment about the security aspects of the stuff? I think that will develop over time, but I will say there's a human inclination that I have seen through my own lens of working in technologies to advance the technology and hold the security on later. And I would just posit to this group, as we develop these things, an eye towards the cybersecurity of cellular-based engineering is a really fascinating topic. And it's going to be much more powerful if it evolves over time with the science than if we get to the end and we're like, holy cow, how does this really work? So now we have to introduce the cyber security.
So I actually wanted to branch off of that earlier and say, like you had mentioned, you think that the need for regulations will develop. Well, historically, we've not been really great at developing regulations as they're needed. Look at what's happening in AI right now. I love AI. I do AI. I hope AI doesn't go away because I love AI, but the regulation of AI has really fallen behind the use of it. And so the security, the regulation, all of this, I don't know how, but I think it'll be important to try and maintain that as we're also developing this, because then maybe we don't get past this stuff.
No, you're quite right. In fact, I would posit that is one of the purposes of this group, by the way.
Yeah.
Right? And its extension going forward is not to bring just us together, but bring other ecosystems that are ultimately going to be related, whether regulatory, whether public policy, whether, many others. So I think that is one of the missions of ICDO.
I think another thing to think about is these are living organisms, right? So if the wolf and the dog, for example, you don't feed the dog runs away. Right? You're going to have to care for
Yes, that's
these
true.
entities.
Yeah.
For them to continue to do
That's right.
I disagree with that. You mentioned factory programs, the opportunity cost. Like, we have an incredible capacity to, induce suffering and really think it's financially viable.
There will always be bad actors, but for the most part, I think we try to take care of these organisms we create.
I think I have a question that just, you said factory farming, so like then I decided that I actually asked the question. How have you thought about like scaling up this in your commercial product at scale? Is it like, is the thought behind it, like, I don't know, but is it kind of like a wet lab meets AI data infrastructure centers, like these complexes that have both, biology and AI in these mega buildings that are pumping these out at scale? Like what is the kind of the thought on how you scale this and commercialize it?
Yeah, so there's some unique challenges owing to the fact that it's a new field and there's no defined market. So that takes a different approach, right? So the conventional approach will be, let me understand product requirements, I'll go and build a product bottoms up, and then take it to market. That doesn't work here, right? So the first phase, which is the phase we're in now, is what I call an exploration and discovery of market and use cases that are representative of markets that seem to be good matches for the intrinsic capabilities of Xenobot. This is purely exploratory. The work is being done within Mike and Josh's labs, right? We don't have our own facility yet. At the end of this phase, our objective is to say, okay, these are the use cases we will actually go and build products for. And what does product mean in this case? Product means, yes, it will embody Xenobots in some way, shape, or form, but it will also have to have what I'll call systems integration around it to be useful within the context of the customer or customers, right? So there's work that beyond Xenobots that we will have to do. To, for example, enable us to communicate with Xenobots, to read their state. For example, to harmonize the Xenobots housing to the context and environment of the customer, right? So that is all hard work that no one else is able to do, including our customers, because they don't know how to use Xenobots, right? So we will have to do that at the beginning. That's phase 2. Phase 3, what I would like to see, and it may take a long time to get to this point, what I'd like to see is that Fauna's focus is on the automated discovery of these function calls, right? And building a library of such function calls at multiple levels, and then partnering with others to be able to bring those capabilities, that knowledge, to bear commercially for specific end applications. That's the long term. I think that's a more sustainable model. What we might do along those lines is spin off companies that are industry specific, right? That we have a close relationship with so that they can leverage at sort of low cost our intrinsic capabilities and bring those to market. Or we would just partner with totally separate companies. But I think this is the approach that we have to take because of the uniqueness of both the market and the technology and field. Any other? Yes.
I want to ask you a philosophical question. So there's the dog and wolf example. I think it's really important to point out that we didn't domesticate wolves. It's a bilateral process of co-domestication.
Yeah.
My local Australian Shepherd, we share saliva. I don't give her orders. We negotiate. And what I've been really fascinated with the Xenobots work is that it's like Mike used the word convince a lot, like 3 times during this talk. It's like these biochemical electrical signals were convincing the agential materials to do something that we want them to do. Another really great example I love is early humans, we know that they scavenge, host hyenas, killing a beast or whatever, because we have, that's what we have to take for. And so then we pass on to cows and pigs, and so it's an ecology of bilateral domestication. My question is, you mentioned passive entities, and then it seems to me that Fauna is working with agential materials, which I'm understanding as having this not dormant, but latent, this potentiality to develop, forms most strange, let's say. Then there's kind of the next step after that is active, so things that are not latent and not really responsive, not really reactive, but co-evolving with future humans, let's say. So I don't want to get into ethics, and I don't want to get into like sci-fi examples. I'm thinking about, I want to ask you how you could conceive of the human as a philosophical subject in the future that was never bounded in the first place.
Well, so let me first react to your first comment. Your first comment, well taken. And in fact, that's the reason I like this as an example, because at the end of the day, the benefit of collaborating with wolves was actually to the mutual maximization of our survival, right? Not just to humans, it was also to theirs. We fed them, we cared for them, right? Provided them nutrition and sustainability. So I do think that that is a good philosophy by which to find and discover the means of collaboration with agential materials, meaning it's bidirectional. Why is it bidirectional? Even if you take the simple-minded approach that I have my objectives, I want it to achieve my objective. If you want a sustainable solution to it achieving your objectives, you better have created an environment that it can actually sustainably live in, right? So I think whether your motivations are intrinsically selfish or not, that's the only sort of sustainable way to achieve it. Your last question, let me make sure I understood it. I think you asked, how do you conceive of, did you say humans that may, could you restate the last part of your question?
Yeah, sure. So you think about these material semiotic exchanges with other species that we've always had and we're having all the time, like viruses, or something doing them, should make you think that they're alive, like that has huge planetary consequences, like the microbiome in my gut, like will influence my mood. And there are a billion examples of that. So if we've learned in a philosophical register that we have never been only human, when we're doing these artificial selection processes with agential materials that are not passive, that have this perhaps like latent will, almost, maybe we could say.
Yeah.
Like, how do you think, like, it's a question of speculation, philosophical speculation. Like, the human is a bounded subject in this integration. Like, how do you see the collaboration between agential materials, their latent capacity to be willful subjects? What does that material collaboration look like? It's a speculative question.
I mean, I think running it to the extreme, I think that it looks essentially like symbiosis. It looks like, we are relying on the agential materials for a variety of purposes that enhance our lives and our survivability in this world. If we've done it right, they're sustainable too, and are resulting, in some ways, philosophical, a benefit from interacting with us. I'm not sure what else I could say on it other than that I would like to see a path towards that more symbiotic relationship rather than a subjugated relationship. I don't know how to execute on that.
So that they're happy.
Lynn Marcos talks about the canonical example of symbiosis is like the light matter and plant matter. Sorry, the fungal matter and the plant matter, then it's a light. That's a process of like negotiation and co-evolution. I don't know, million years, whatever. So like to have, but that seems different to me than experiments we're using like artificial selection of agential material, in which we're like co-becoming, let's say, with xenobots that deliver that change us. So in the future, I suppose, like, what would be the analog to a lichen for human robots?
I see where you're going.
Can I?
Yeah.
So if you flip the equation, you are,
You are
yeah. He's an author, I can't pronounce his name very well, but he's argued that actually the wheat grass of wheat has domesticated humans. in the sense that it has basically given humans what it wants in order to propagate across the world, literally across the world, right? And it is one of the most prolific, in fact, more numerous than humans on the planet, right? So that sort of, comes like whose ownership, who's doing what to whom. I mean, we can say that we are the messaging lead, but if you look at it from the other perspective,
100%.
yeah.
If I could add to that too, I mean, there are multiple forms of symbiosis, one of which is mutualism, which is kind of what you're talking about. There's also parasitism. In this case, I think maybe more accurate one is that we're the parasite, and the neurobot is the host engineer, making it do our will, but keeping it alive so that it can continue to do our will. Maybe that's not a great, commercial story, but.
Yeah, can I give you the information about that?
It's interesting to push it even further from like that script here. Everyone's always up in arms because AI is going to be a singularity and will never exist. But that doesn't seem likely because a computer wrote it down. The agentic theory is like, what if one day we're like, oh, damn it, like we're part of them. If we are choosing these things because when in proximity and correct conditions, they join to form this collective, it's more intelligent than the pieces, and we create so much of it. Before you know it, they are one conscious entity, and we are the thing that they're using in order to get what they want. And I wonder, society. I wonder if you would even notice, and what that would be like later.
The C word, something progress is great, but there is a question about, not just the agency of these things, but is there some sense in which they are, phenomenal figures? I have no idea how you see this.
If you look at it, our brains are essentially a society of neurons. I mean, if you look at it, so that's how it has scaled naturally.
Well, this is one of the potential directions that any symbolism relationship. Look at AI, we are still speculating, in the next 100, 300, 500 years, what's going to really actually change in terms of all this AI impact. And one of the potential speculations is that it's going to be fusion. It's going to be essentially fusing us and AI. And it's potentially true. The same thing for agentic material. I think, we could eventually actually fuse our together.
Okay.
It's a one that actually potentially harmonic consequence because it could go the other way.
Okay, thank you for this wonderful discussion, and let's thank